This is a high school geometry lesson about intersecting lines and angles inside of circles and all the relationships there to it. So let's begin with a circle. Here we have a circle. Remember that we can tell that the circle, because it's the center of it, is right there. Cool, huh? Okay, I'm going to talk about an angle first. We've already done this, but let's talk about it again, what it's like to have the angle come into the circle. Okay, so here's an angle, and it's coming to the circle right there. It's not yet in the circle. It comes on in. Now it's halfway across the circle, and we recall that this is the definition for the measure of the intercepted arc. So the angle intercepts the arc. The intercepted arc has the same measure as the central angle. Remember that the central angle is the angle with the vertex at the center. Who'd have thought? Okay, cool. So, by definition, the measure of the arc is the same as the measure of the central angle. Okay, well, let's play around a little bit more, and let's bring it back like this and go a little bit more this way. Bring it straight across. Okay, now then, the vertex of the angle has gone twice as far. When it was right here, it was the same. The central angle was the same as the measure of the arc. Notice now that the arc is bigger. This is twice as far. The angle has traveled twice as far as it had. And, by the way, the arc that's intercepted is twice as big. I wonder why that is. And if it is, I wonder why it always works. Could it be? Yes, it is because it is round. The circle is round. The curvature is always the same. And so when we do an operation like this, we're taking the same amount. Now, that would not be the same. That would not be the same if this was a square. Okay, if I had a square here, and I wanted to say, how long is that? Okay, well, cool. It's that long. And how long is that as I move it around? Well, no, that's going to be different. Do you see? Or that. That's going to be different. Why? Because the shape is not always the same all the way along. So if we're taking what's in between, that's just not going to work. Why does this work? This works because the circle is, yes, you knew it, round. Okay, for a moment here, let's take the angle and make it extend it and make two intersecting lines. Okay, so instead of seeing it as an individual angle, I'm going to see it as two intersecting lines. We have the same thing here. You can just pretend that that's the angle and it does exactly the same thing. Okay, so now I'm going to look at here right at the central angle position. So we have two central angles, well, four actually. We'll talk about the left and the right one. So here on the right, here is the arc, which is the same measure as the angle that subtends it, and over here is the arc and the same. Oh wait, look, these are vertical angles. Since they're vertical angles, they're congruent, so the arcs are congruent. How about that? Okay, you know what else I could do? I could just, go all calculation crazy and say, I'm going to calculate this angle in a different way. So, for example, if I know the arc, then I know that the central angle is the same. But I'm going to say, you know what? If I add these two arcs that are exactly the same length and divide by 2, you know what I get? I'm going to get the same number. So if this is a 60-degree arc, this is a 60-degree arc. Both of these angles are 60 degrees. But I'm going to, I just like calculating math so much. So I'm going to say 60 plus 60 divided by 2 is, 60. And that'll work. Too much trouble. I won't do that very often. But look what happens here. Look when this intersection goes traveling. So the intersection comes over here. Notice that the left got smaller, the left arc. The right arc got bigger, smaller, bigger, the same amount. If you look at it and you actually take a tape measure and measure it, you'll see that it is still the same length together, added together as it was here. And you know what? No angles were harmed in the making of this experiment. These two angles are still both 60 degrees, and the two arcs still add to the same length. Gosh. I wonder if I can just do the average again. Yeah. And why is this the case? Oh, let me remind you. It's because it's round. The curvature isn't different. Like if you were going to try to do that here with this square, it just ain't going to work. See? How long those two are added together is not the same as how long those two are added together. It's just not going to work. Okay. So again, because it's round, what we have then is that we can always, with an intersection inside the circle, we can always add the two arcs, divide by 2, average the two arcs, and we will get the angle measure. And that's a theorem. Who'd have thunk it? I know you're surprised. Here we go. Go ahead and write down the theorem. Pause it till you get it written down. Then we're going to start on another thing here. Okay, what if we now say, okay, we know that these add up and you can average and do it. We can average these. We can average these. What if I were to put it right? Okay, look right here. Look right here. I get little teeny tiny. So now I'm averaging this big one and this little teeny tiny one right here. Yeah? Little teeny tiny one. Okay, well, I get it teenier and tinier. Okay, there's this little bitty angle and then this big long one, and I average them and I still get 60. What happens if I go all the way to where this is a tangent and a secant? What's going to happen then? Well, I guess you could say that the angle here is 0, and the arc here is 0, and this is really big, and I add them up and divide by 2, and guess what? I'm still going to get 60. You know, that's true. Let's look at it and play with it for a minute and see if we can figure out how that works. Okay, so I'm going to put some other lines here that'll help me do it. I have, think first about how this secant is working. Okay, the secant can go like this. It can change at the angle and still be at the point of tangency. And as I rotate this around, I notice that the secant is going through 180 degrees. Okay, and where my secant is the portion of the 180. Well, you know, it's also chopping off this circle. So the length of the circle, in other words, the arc, is also good. Look at it. As the angle changes, the amount chopped off of the circle to be an arc changes. And you know what? With a circle, the pieces of it, how much have I chopped off? Here just a tiny little bit, and over here 360 degrees. It goes to 360 degrees like any circle would. No big surprise. And since the circle is round, it's consistent as it goes around. It changes the same, and we can rely on it. So in doing that, let's look here and see how we can deal with that. Okay, I can write myself, since it's round and since the line is straight, we have the relationships that remain. So we can do a little relationship here that says the angle measure, that's going to be with the secant and the tangent. The angle measure is to the line, the whole line, how far it moves, okay, as the arc measure is to the entire circle. Okay, well, I know the line's 180, so I can do this. The angle is to 180, as the arc is to 360, because I know that the circle is 360. Okay, well, I can just butterfly this and multiply. Oh, no, wait, not butterfly. We're going to apply the theorem that's the postulate, whichever one it was, that says that the product of the means is equal to the product of the extremes. We're going to say it that way because that's the right way to say it. But what we're going to do is butterfly. So we'll have 360 times the angle is equal to 180 times the arc. Divide both sides by 180. You'll have 2 times the angle is equal to the arc. Oh, wait, we just saw that, didn't we? We just saw that same relationship. So now that what we can see is that when the vertex of the angle that we're talking about is inside the circle or on the circle, the angle is always going to be twice the arc. The angle measure will be half, excuse me, I said wrong. The angle measure will be half of the measure of the arc, or the arc will be twice the angle. So, what do we have here then? Our basic definition. The arc measure is the same as the central angle. We pull it around. We see that we can do an average all the way inside. We pull it all the way back. We've already done that theorem that says twice as far away is twice as much. Okay, and now we have that the angle itself does not have to be actually inside the circle. It can be a tangent and a secant. And guess what? That is a theorem too. Here we go. Okay. Please make a note of the theorem. And here is where this portion of the lesson ended. You'll need to get the second portion. The link is available, but this portion endeth here.